All right, welcome back. This is the second video dealing with chords in a circle. We're going to talk a little bit about chords within a circle that are measured from the center and that distance here. So I know that you should have a circle on the back of your other one. If you want to flip that page over and work with me there, that would be awesome. Again, if you're following along, you're just taking notes, you can sketch this on your own as well. All right, so what I have here is a circle with two chords drawn. Now, the chords here are going to be a little specific, and what I want to show you is the relationship between the chords and their distance from the center of the circle. Okay, again, I'm going to have to pick a point pretty close in that center, not on either side. Okay? But the way that we measure distance between a point and a line is we want to draw another line that goes from the center to the chord, and it has to be perpendicular. So the way that I'm going to do that, and if you're just sketching now, that's fine. We'll do a little more specific on our next class. What I'm going to do is I'm going to take that 90-degree part, and I'm going to line it right up here. And I kind of spaced these so this would work out pretty well. But I want down here my protractor to be right on the line that I drew. And I want that 90 degrees to be right here in the center of my circle. And I'm just going to put a single dot right here so that I can come out, and now I can sketch my straight edge. Now, I am going to draw this all the way across to the other side. Okay, but what I'm really focused on is this distance from the center to this point here, and I'm going to call point D. And because I made it 90 degrees, I'm going to draw in my little 90-degree box. I'm going to measure that. So from I to D, and right here at the center, right along that looks like pretty much right at 5 centimeters. Okay, which I didn't even plan. That just worked out really well. Okay, so I'm right at 5 centimeters there. What I'm going to do then is the same thing on this side. I'm going to line my protractor up right on the chord, and I'm just going to slide it until 90 degrees right at the center of the circle, so I'm right about there. I need to back that up a little bit, slide down just a bit there, and I'm going to put my point again. And I know that's a little tough to see, but it's right there. And I'm going to connect those with this. So I'm not drawing a diameter. There's an angle there. But I'm going to have a 90-degree angle there, and I'm going to call that S. As I measure from S to I, what I'm seeing here is I am also right at that 5 centimeters. Meaning that ID and IS are congruent. Okay, so I'm going to make that note up here. Segment ID is congruent to segment IS. Now, that's the idea that we're going to work with here. What we're going to say is that the chords are equidistant from the center. Okay? And that's our important key aspect here, that the chords F, R, and NE are the same distance away from the middle of the circle. What happens when we do that is a few things. Number one, if I measure the chords, I'm going to be there right at 12.5 centimeters. And right over here, I'm also going to be right at 12.5 centimeters. And that's the really cool thing. If that happens, if the chords are equidistant from the center, then I'm going to be able to say that FR, the chord over here, is congruent to NE, the chord over here. And sorry, I know my camera a little far in there, so I'm going to try to a little further away so we can see all of it. There we go. Okay. So if the chords are equidistant from the center, then the chords are congruent. Okay. Now, the other thing that's going to happen here, one of the real neat parts is that radius that I drew right here is also going to become the perpendicular bisector of the chord. Okay? And if I measure that, I'm going to go back here. I know I was at 12.5. When I get right here, if you can see that, that's right at 6.25. So this is 6.25, and this is 6.25, and this one is 6.25, and this one is 6.25. And you're going to get the chance next time we're in class to do this measurement in your own circle. Okay? And so what we're going to say here is that segment ID is perpendicular to segment FR, it's the perpendicular part, and that segment FD is congruent to segment DR. Okay? So that's a perpendicular bisector. And the same thing is going to be true on this side. Okay? IS is perpendicular to NE, and NS is congruent to SE. Again, that's the perpendicular bisector. And all of that happened because we measured the distance using perpendicular lines. Okay? So I can say that those are congruent. Now they're also congruent to each other because the entire chord is congruent to the entire chord. So half of the chord would be congruent to half of the chord. Okay? The last thing that's going to happen here that we're not going to talk a lot about is that these arcs, NE and arc FR, are also congruent. Okay? We learned that in the last one. Congruent chords have congruent arcs. So arc FR is congruent to arc NE. And that's based on the last video. Congruent chords cut off congruent arcs, even if I don't have the angles measured. Okay? I could, if I drew a radius from here to here to here, have an isosceles triangle, these two have an isosceles triangle, or deal with right triangles to find out how long the radius is. We'll see some problems like that in class. The other thing about this, though, and I'm going to give 2 more points, which I didn't account for in my word here, so I'm just going to have to make up some new ones. So we're going to go with X and Z over here. But what happens is this perpendicular bisector not only cuts the chord in half, it's going to cut the arc in half. So arc FX is congruent to arc XR, and arc NZ is going to be congruent to arc ZE. Okay? So arcs also bisected. Okay? All that's going to be true. Again, we're going to put all these in words. We're going to see these written out in more detail in class, but I wanted you to see what's going on so you can start to work with these a little bit. Okay? I'm going to switch gears just a little bit here and come back over to this paper. Now, we're not going to fill in every single bit of this today, but these are good things. These 4 things are what we just talked about. Central angles, congruent arcs. I can zoom in a little bit more here so we can see. Okay, in fact, I can get a little closer, maybe. There we go. Central angles, congruent arcs. So the idea here is that if I draw 2 angles, even if they're in different circles, if those are congruent and the radius is congruent, then the arc is congruent. I'll put a little mark on those other radii. Okay. If the radius is congruent, meaning the circles are the same, and the central angle is congruent, then the arcs that are cut off are congruent. The same thing is going to be true over here. Congruent chords have congruent arcs. So if I draw 2 chords down the side, and they don't have to be parallel or anything, but if the arc is congruent, the chord is congruent, and vice versa. Okay? You know it in either direction there. Over here, center lines perpendicular to a chord. So if I have that, I draw a chord, and I draw that at a right angle, then that is going to be a perpendicular bisector. And that would work the other way. If I know that these are cut in half and it goes through the center, I would know that that's a right angle as well. It's going to help us out with some triangles. And then lastly, equidistant from center. That's where I have the two. Better center there. And so a chord up here and a chord down here. If this measurement and this measurement are the same, then the chords are the same as well. So if you're filling those in, this is great. Let me see if I can get them all on one screen here. There we go. And having these filled in is awesome, but this work with that piece of paper that we did is also great. So check this out, take your notes, and we'll talk to you soon.